Thanks everyone for joining the, I almost said January meeting of the Microsoft Data Platform Virtual User Group. If you, and welcome people who are here in person or people are watching us later online. And just a reminder, if you are watching in person and you missed something, all these meetings are uploaded shortly after we finish, so you can always watch it later on YouTube. But without too much more delay, I'd like to welcome our speaker, Tom Grohser. He's a Microsoft MVP for SQL Server and knows a truly frightening depth of information on SQL Server performance. He is here to talk to us about how to manage dozens to thousands of SQL servers. And yeah, you're kind of a frequent flyer, so without spending too much more time on the intro, I'll just turn it over.
Okay.
Thanks,
Okay, I will take over. I'm sharing. Okay, 50-50 chance. Zoom did not blow up. That's good.
Yep, I see it.
And I will stop my video to preserve bandwidth because there's no point in seeing my face. The slides are much more important. I apologize if there's a slight interruption at some point. I noticed over the last couple of days the place I'm currently at 9 p.m. my time, which is about an hour from now, I have like a 5-second internet interruption. That might happen. Don't worry, I will be back. It always lasts 5 seconds, and then it's back. Okay, so if you have questions, that's a good question how I get them. I will stop and ask if there are any questions and then look at the chat and stuff like this. But for now, let's start. So we're talking about how to manage some and many SQL servers. And I hope you can see the slides. And thing is, so a little bit about me. I'm with SQL Server for 29 years. To put this in comparison, last year at the Data Community Summit, Microsoft celebrated 30 years of SQL Server. So I got it as a 1-year infant and tried to keep it alive ever since and work with it. Here's my contact info. I try to answer emails within a week. I usually do it on the weekend. So if you want fast responses, send them on Friday afternoon. If you want slow responses, send them Monday morning. That's thing is, yeah. So why would you automate? And I'm automating SQL Server and everything around it for many years, because usually I work in companies that have more than one SQL Server, many more than one. And thing is, and over the years, I had different reasons for the automation. But my number one reason is consistency, not what many people want to automate to reduce the work. So I don't want to like install SQL all the time or so. For me, it's not about the work of installing. Yeah? Of course it is. Yeah? I mean, if you manage like 600-700 instances of SQL Server, you don't want to sit there and click through the setup every time. But the consistency part is more important. If I manage a large number of SQL servers, I want them all to be identical. I want them to be set up the exact same way. The first tempdb file is always there. This setting in Windows is always changed. This setting in SQL is always changed after we install it, because that works for us, and that's why we have it. Of course, whatever automation you build must be able to deal with not having that change or setting by default, because you might have to run some third-party software that needs that to be in a different state. But the important thing is that it's not just for the scale, because you need hundreds of them, which is my number 2 reason to automate. For me, number 1 is consistency. Yeah? Cost reduction, that's not for me. That's usually for my boss and everybody above them. But it's, of course, important. We all have to deal with budgets and reduce as much as we can. And one of my favorite, I can't put it any higher. I have to do the business stuff first, but then I really love to do more exciting things than installing SQL Server and reconfiguring it and restoring databases and backing them up and doing things with them, maintaining them. So I automate that out of my way so I can do more exciting things. And what I've learned over the years is that teams don't scale. You can't hire 200 DBAs to handle 20,000 instances. You can try, but it will not work because you will not find the people. And you will spend so much time coordinating them. And just imagine if you have 200 DBAs and you have to make a change in your way you're setting things up till all 200 are actually aware of that. That's months. Yeah? And I've worked in companies that had more than 100 DBAs. It was an insurance company and it was not fun. Everything took weeks and months to do because to get the whole team working. Yeah? Automation can scale. If I had cases, we changed the setting, we pushed it out to the fleet. 5 minutes later, all 700-800 instances had the change. Everybody was fine. Monitoring picked it up. The change was executed everywhere, and everybody could go home. Yeah. When doing this manual would have taken probably the whole weekend. All 5-6 DBAs that worked there, automation did it in a few minutes. So why build automation and not buy something? My biggest problem is I haven't found a tool that would do what I needed so far. I've played with all of them, orange, red, green, purple, whatever colors their logos and corporate identity have. They are not for large scale. SQL is mostly deployed in small and medium shops. Large installations of SQL servers are rare because large companies are rare. There's not that many of them. There's a couple of thousand on the whole planet. That probably translates to maybe a few hundred in the country you live in if it's a big country. And that probably then translates to 1 or 2 per city that you live in. And that's it, unless you are like in Silicon Valley or New York or something where it's a little bit more, but even there, it's not thousands of them. It's dozens of them that have large SQLs. Don't forget, there's other good database products as well, and not everybody uses SQL. So, yeah. Was this a question or some? No. Also, most of the tools that I think is they were not, it wasn't a problem that they couldn't like do the management or so in some cases. They had no underlying understanding of the infrastructure. Like, is this an HA machine? If I see it even with simple monitoring tools that I get like alerts from the DR site that it's not accessible. Yeah, because it's DR. It can't be accessible. If it's accessible, I need to buy a license. So it's inaccessible right now. Yeah, I mean, some tools getting better at that, but if you have complex scenarios with like 2 or 3 data centers, in addition to your primary data center, most of these tools don't have the metadata to deal with that correctly. So that's one of the things. Yeah, you can try and buy multiple tools and try to make them work together, but that ends up being much more complicated and cumbersome than just writing from a clean slate. And if you did what I did, that built like a framework that you can use to automate, and that's what I'm talking in this speech here today, a framework that you can reuse from every time you need something to the next time and just improve it and improve it is more helpful than things. And why is there no tool? It's really hard to build a generic one. So after I did it like twice, I sat down for a couple of months and tried to figure out what would I have to do to take whatever I learned so far and make it a generic tool that everybody could buy. Yeah, put another one on the game field, and it turned out to build something that works for every case. It's close to impossible. Yeah. I stopped when I tried to define the underlying storage so that you could request storage automatically, which is a big part of automation. If you have to write it for your one company that you have that you're currently in, and you have this one or two storage product, it's fine. There are hundreds of storage products out there. If you have to write something that works for everything and all the weird things they have and kinks and quirks they have, it's not feasible for any company to actually do that. So that's why there's no limits. Good. When we automate, we have to find out how much automation we're going to do, because if you write something that does everything perfect and needs no human interaction, and then it turns out you only have 2 instances of SQL Server, your boss might not be happy with you because you just spent 10 years of working to do a job that you could have done manually in like 3 hours. But on the other hand, if you have several hundred instances and you're not automating anything, that's the same wrong approach. So the first level of automation is none. You would be surprised how many times you find that. Every DBA does whatever they think they do. They have like 2 or 3 of them. They probably have a coffee meeting in the morning and kind of synchronize, but then they wander off and do whatever they want. Not as uncommon as you think. Second level is you have guidelines. Someone wrote down, we do this and that when we install, we do this and this to do backups, we do this and that. But it's guidelines. It's not like you have to do it this way. It's more like we do daily full backups. Yeah, schedule it whenever you like. That's more like guidelines in this way. Thing is, or the next step in the next level is step-by-step instructions, which is to install a SQL Server, we open up this share, pull down this exe file, run it. On the first screen, we click here and there. On the second screen, we click here and there. Yeah, super cumbersome to make, but it's much easier than writing code doing all that. And again, for small shops, this might be sufficient. Yeah? It's just you need to decide where is the work. Yeah, you will still automate your backups because these are things you do on a daily basis. But if you only install like 2 SQL Server per year, it might not be worth it unless you need it for the consistency. Yeah, thing is. The next one is template scripts. I call them like this. Is the famous DBA downloaded or created its own script, some PowerShell magic or something, where you open up the script, you copy it to the new machine, and you change everything in the script to reflect the new machine. So you basically go through the code and fix the paths, the names and everything, and you hopefully get all the places where it needs to change, and then you run it. That is very common. I've seen this even in large corporations. That's the way it's done. Problem with that is if that script is not super maintained by everybody, you end up with a big mess. And then if there are 2 or 3 versions of that template, consistency is gone. The next level is what I like to call parameterized scripts. It's basically the same as the templated scripts, but everything you have to change is like at the very top of the script. One great example of that in the area of maintenance are OLA's backup and maintenance scripts. At the very top, you changed a few things that adopted to your infrastructure, and then you just run it. Yeah, and most infrastructure as a code, the new fancy things, like they work like this. They have a script that knows what to do, and it gets a couple of input parameters to do that. But the script itself has no idea how the whole thing works together. Can you please mute if you're not asking questions? Thank you. The next one is you have a configuration database, and this one is used by scripts. So instead of having copies of the scripts and changing the top or the whole script every time, you actually have all the options in a central place in a database. Guess what? We're database people. We like to put things in databases and not into some XML or JSON scripts, because databases are a very good, consistent way, and you can use for searching and finding stuff in there in a very good way. And the level where usually I'm trying to automate now and where I have my framework at is the CMDB and control plane. Control plane is basically scripts are no longer there. It's actual code and agents that understand what to do if they read the configuration metadatabase. Yeah. Whatever is in the database, you don't change it on the systems, you change it in that configuration database. The agent picks up that there was a change in the database and executes out on the machines. Yes, the holy grail that one day in the far or very near future, depending how fast it takes over the world, you will add artificial intelligence to the whole thing. Probably not to deployments and stuff like this, but where I could see AI being really good is in looking at the data and from the systems and see if there were any changes or pattern of changes or patterns of failure that can help you predict upfront that you have like a systemic problem. So a couple of years ago, I worked for a company where we ended up having 8 million corrupt pages across all our SQL servers because a faulty driver for the storage system was rolled out by the Windows team, and that an AI might have picked that up faster than the DBAs and figured out faster than we did where it came from. And so we might not have ended with 8 million corrupt pages, but probably only with 3 or 4, which would have made a huge difference because way less work to fix. But yeah, that's in the future. I haven't seen anything practical yet being used. Good. The next thing when you think about automating is you have to communicate with users and other DBAs and other teams, because if your communication to other places is key. The bigger your organization gets, the more you have to communicate to others what you're doing so they're not surprised. So if you're a small shop, you yell over to that one developer that you have that you're going to take down this one database, and he knows and acts accordingly. In a large corporation, this other developer might be sitting in a different country in a different time zone and not even hear you yell at the time, and then a couple of hours later be surprised that something has changed and his stuff doesn't work anymore. Yeah. So level one is start talking to each other. That's important. I've seen companies where this is avoided and it's not helpful, but it's also not very consistent. It's you're at the water cooler or at the soda dispenser and you're agreeing to something, then you both understood it's slightly different. You go back to the desks and then you work into different directions or something. The next one is manual requests, also known as emails or something, where at least you have a trail and a written down information, what was agreed on. After that, a ticketing system that tracks who works on it, who works on it, how long. Well-formed requests is basically the tickets get a special UIs for the cases. What I've seen some companies actually successfully build is like interfaces for new database. What's your requested name for the database? What's the requested size? What is it going to be, OLTP or data warehouse or something? You need high availability? Yes, no. Is it for production or for development? So that the standard questions that you put into a form so that everybody answers them the same way. Because if you ask people to write you an email with what you need, everybody will write something different in a different order, so you need a human being to decode it again. If you have a well-formed request, you can make this a very standardized email or ticket, and that makes it much, much easier for everybody else. Yeah. Then next step after that, if that is not sufficient enough, you can actually create your own portal and API. For that, you will need some software developers that understand all that magic REST and other API stuff. But it will allow other teams, and especially in larger corporations, other teams to hook into your interface directly. So I often use a portal or API provided by the IT or storage or Windows team to request things like a virtual machine or request a server. So I give them the information they need in the standardized form, and then I ask the software development teams or the DevOps teams or even regular operational teams, if you need something from me, please go to my portal and ask me in a standardized way. And the last thing is, the larger a corporation is, the more you will have to look at things like approvals, because in a small company, it's usually one person approving everything. In larger corporations, it's hundreds of people approving very tiny parts of the whole thing. And you might spend more time in chasing down approvals than actually doing practical technical work. So integrating your automation into the local company's approval system is very critical, because you don't want to build or buy a big machine and spend a lot of money unless you know that someone actually sanctioned it and is willing to pay for it. So next step when I start automating is I think about, what do I need to automate? Yeah. Number one, repeating tasks. I don't want to do the same thing over and over again. Yeah. I know there's people that love doing that. I'm not one of them. And most of you, if you're in this session, probably don't want to do this either. Yeah. The most common thing that repeating tasks and that pretty much everybody automates, even without knowing that they're doing it, is monitoring. So like, let's check every 5 minutes if my machines are still alive. Nobody wants to do this manually. So you buy monitoring software, and with that, you actually automated your monitoring. Yeah. So step one, check. We have something automated. Yeah. But as we said before, depending on your size and what you're doing, creating new databases might be a common job. Exactly. Automate myself out of a job, and then I'm available for promotions. Perfectly said. Things, yeah. Number one, monitoring, telemetry, and config collection. So I distinguish between monitoring and telemetry. Monitoring is something I want to do like every 5 minutes. Telemetry is something I want to do like once a day or maybe once an hour, because doing it every 5 minutes makes no sense. So, for example, collecting all the permissions of all databases. If I do this every 5 minutes, the systems are not doing anything else anymore. Yeah, but if I do it once a day, I kind of have a history, and if something changes, I will notice it from one day to another. If something changes 5 times within a day, these details are lost. But again, you have to find a balance between craziness and what is practically doable. But it's definitely not monitoring, but it still should happen on a frequent thing. I even had cases where I could like check, collect like the schema definitions of all the tables and everything. I did it like once a week on the weekend, and then other things like list of databases or so, I collect like once an hour. There's very few things I collect every 5 minutes, except for information about high availability and space, like available disk space or so. I check every 5 minutes, so that if I have a runaway process or so that suddenly requires storage in an insane amount, I catch that quickly. But that's the only reason. But all this collected data after like a day or so gets aggregated to like a daily thing, is because it's interesting to see how the disk space is used like every 5 minutes, but not after 24 hours. The 24 hours, it's good enough if I have like one data point per day. Thing is, of course, things like backup and restore, you want to automate. That's also something many people have done. And thanks to Olaf for his great scripts. There's some standard coming into SQL Server. And thing is, yeah. The same thing goes for maintenance, index rebuilds, statistic updates, check DBs, all that. It's basically things that you run on a very frequent basis. Yeah? If you have 1,000 databases and you need to run check DB, you don't want to sit there and do it manually. It's just not feasible anymore. Yeah? If you have 5 databases, you may not. I still would automate it with 5 because I just don't want to forget about it, and I want to be able to like do more interesting things. But yeah. The next one is building tasks, like create new instances, new databases. This is not repeating, but it still might happen a lot depending on this. I worked for companies that had way more databases than employees. So new databases could be a very common thing. Constructive changes, like add permissions, add jobs, migrate databases. It's basically things where you're not removing or destroying anything. It's just you're adding something. If that's wrong, you can always remove it again. It's not, you're not destroying anything. This is what I call constructive changes, because that's very safe. And if something goes wrong, there is usually no harm or no, besides extra work to fix it. But it's not like the next one where you have destructive changes, like removing something. Yeah. And you will see with the next point, well, let's bring the next one in immediately. Oops. Decommissioning. I even distinguish between destructive and decommissioning. Destructive means just I remove it. So I would, when I automate like removal of a database, I'm not just someone requests it and it gets approved. I'm not immediately dropping the database and destroying it completely. Yeah, I will do a final backup. I will mark that backup. It needs to be kept for many years. It cannot be deleted or optimized or something. And then I will detach that database, take it offline basically, and then wait like a week or so if someone complains. If it's near the end of the year, I might wait till the end of year processing is done. And only if I don't see any complaints, I will then approve the final step and say, okay, we can decommission that. And I just keep like a queue of things that are initiated but not completed, so that it's easy to track down and see what's going on. So why did I not list patching as something to automate? That's because I rather spend my time convincing my managers not to patch. And don't get me wrong, all my machines are at the latest patch level. That's not thing. I just don't patch them. And I will let you in on the secret. Patching, in my opinion, and everybody is entitled to have a different one, is essentially an in-place upgrade. And that's technically how it works. Doing an in-place upgrade between 2 versions of SQL Server or applying a CU is technically the same process. They're doing a little bit more checks with the in-place upgrade, but patching is, it replaces what is there and reboots the machine basically, and or at least restarts the servers, and then hopes that everything still works. And I don't like that. So when I automated all the other stuff, I automated 2 things on the page before. I automated migrating databases, and I automated creating and installing new instances. So instead of patching, what I do is I request a new machine, because these days everything is virtual in VMs anyway. So I request a new machine, install it to the latest level with all the patches installed, do all my burn-in tests, make sure that instance is running perfectly, and then I migrate all the databases to the new instance, and then I decommission the old one. So I never have in-place upgrades. I don't have to write patching code that figures out how to patch, which is actually not that easy, because how do you know that the patch is actually completed and successful? I have not found a way to definitely figure that out. If you know, let me know. I haven't done. I always found edge cases where patching was stuck somewhere in the middle, and the instance appeared to be patched, but then when you tried to apply the next patch, it wasn't. So I gave up on that and says, freshly installed machines, you can always patch because that always works. But especially if you are security aware and you start messing with permissions in MSDB and then apply patches, they don't always work. So that's why I don't automate patching. Could you do it? Sure. I'm just not doing it. When I start these projects, I spend usually a couple of days agreeing with everybody else on what I call engineering principles. This is basically, let's make all the decisions up front and not wait till we have to make a decision. It's like a prenup for engineers. It's like we're still friends right now at the beginning of the project, so let's discuss how we're going to do everything. And then when we have to make a decision, we just look at the agreed things and follow what we agreed on, so we don't have to fight it out every time, and then change our mind over time and then have very inconsistent stuff. So what do I mean is, I sort in every company my engineering principles from the highest to the lowest. What has the highest principle? I will give you two different companies as an example. First, a financial industry company, so hedge fund, bank, something like this. And the second one is an online gaming company. So like someone who runs like one of these multiplayer ego shooter or something systems that are out there. Yeah, they have very different requirements for their databases. Yeah, and so the engineering principles will be different. So, for example, the most important thing in the financial industry is that you can recover and have no data loss. Just imagine you do like you charge someone on their credit card, and then you lose the record of doing it. They will be unhappy, and your company will get a very bad reputation very quickly. Yeah. While on the other hand, an online gaming company, if you lose a little bit of data, yeah, some player is unhappy, but that's not going to change. Or thing is, for them, most likely availability is going to be the highest priority, because if gamers can't game, they get thing. In the financial industry, the second most important one is consistency, integrity. While on the gaming platform, it will be scalability and performance. Yeah? So you can see different priorities, but still, for the gaming company, we rather have the systems a little bit slower, but they're still running than we have performance. Yeah. So where you need these engineering principles, now you have to make a decision because you can choose between performance and availability. Since availability is higher, you will choose the availability solution over the scalability solution. Yeah? Still doesn't absolve you from making it fast enough. But again, it's a little details that every time you have to make a decision, if we turn this setting to 1 or 2, one, it's the high availability is better, and 2, the scalability is better. Okay, let's choose option 1 if we're a gaming company, and we'll see where in the financial industry we will end up with. Yeah? Financial industry security is more important. Gaming stability is more important. Now we finally get to availability in the financial industry and to security on the gaming platform. It's these levels, and I think it's it. So let's go to the end of the list. And the interesting part is that for the financial industry, cost is usually at the bottom. Doesn't mean they don't look at how much things cost. But the reason I put cost in red on both of them is wherever you put cost in this engineering principles, none of them below will ever be discussed. Because cost will always, every feature, whatever you do with, if you want to build manageability, it will cost you money to do so. So if cost is more important, you will not be able to do anything that is below cost. So unless cost is at the bottom, you have to understand that basically everything that's listed below cost will never happen. And that's important because you might agree to, okay, we're not doing testability or manageability or maintainability here. Yeah, that could be a choice in the financial industry, but you have to explain to your bosses, then you made that choice. That means the systems over time will perform worse and worse, and that's what we have to deal with. Yeah. So, but it saves you a lot of time while implementing if this priority list exists. If not, you have to reevaluate that every time, and then you will have very inconsistent things. And I've seen this in companies where like 6 systems are built for high availability and the other systems are built for consistency, and then they try to move a database from one to the other, and then it's not working as expected anymore. Just not fun. So what's the bare minimum that you need to build a nice automation system? Yeah? You have 2 areas. You have the managed clients, which is basically 1 per instance of SQL Server. It's every, you could call this a SQL instance. Yeah. But since you might also want to support cloud things, which you could use serverless or other options. There might not be an instance. Yeah. So I try to avoid use the name instance. So you have a managed client, something that you want to manage. Don't confuse it with managed instance from SQL Server. That's also something that exists. And you have your central machines that basically hold that central CMDB, where you have all the information that you need, all the changes, everything goes in there. This is the one where you know how your infrastructure looks like. It's all in there, and it starts from there. What I usually create is on each and every machine a little DBA database. Yeah? You pick a name that is not on any system, and you put the same thing on each and everything. And I've seen this a lot. People just do that, like where they put in either Ola scripts or have their own set of where they put in who's active, all these things. It's one little DBA database that is online and active. And yeah, I have that too. And I tried to have all the local configuration, have a copy of the local configuration from the central CMDB. So, for example, the central CMDB would have is we do on the client X, we do full backups every day at 9 p.m. Then that schedule would be stored in the local database as well. So if for any reason the central management is not available, the local machine can still perform the backups at 9 p.m. So while the central one is the one where you manage everything, the one that is used to actually automate each and every instance is the local copy, so that if the central system fails, you're not stopping making backups everywhere, or you stop monitoring everything. Yeah, that would be catastrophic, and you don't want all your SQL servers depend on a single one. That's never a good idea. Yeah. Then you need something that can talk to each and every client. Yeah? And over the years, I came up with, in the early years, let's say in the early years, I came up with some very crazy ideas. Like I once built a system where I had like 500 linked servers to each and every instance from my central machine and managed every machine through that linked server. It worked. It didn't work well, but it worked. What I came up with over the years is very, very simple C# Windows servers that just reads from the central CMDB from kind of a to-do list, and then executes step by step and can do very basic things. So one basic thing is it can transfer records from the central CMDB to the local CMDB or the other way around. It can execute a store procedure, capture the result set, and store it somewhere. The basic things you need to do in managing systems. There's some special ones that can like read performance counters or deploy that local DBA database on the client. But the basic execution agents are just very simple tasks. I've found over the years that having agents with simple tasks and then having a workflow in the central CMDB to orchestrate the simple ones is much more flexible and faster than having agents that do very complex jobs. Because again, we're database people, we know how to do database. The more I can avoid writing complex code and anything else, it's fine. If you have someone on the team that is a C# or any other preferred language genius, you can do that. But keep in mind, if that guy goes away, a lot of knowledge goes away and you might not be able to find someone again. And that execution agent can talk to that local DBA. And that's usually the only database I let it talk to. If I then have in that local DBA database store procedures that can execute system tasks and deal with the permissions. Yeah. The local execution agent is basically a fancy name for SQL agent. I'm hoping one day I can replace SQL agent with something more secure. But for now, I use SQL agent that picks up everything like the backup schedule. It says, oh yeah, I have to do a full backup today at 9. Let's do that. I have to do another log backup in 5 minutes. Let's do that. In 5 minutes, it will do the same thing again, and so on. Usually the central CMDB, as we talked before, has some sort of an API where other people can put in requests or ask for information. If you're super lucky and you find someone in the company that can actually make a UI, you can put that on top. And you might create reports that don't go through the API, but directly query the CMDB for performance reasons. Give you all kind of information out of that. So these central execution agents also collect the telemetry from all the instances, like the list of databases, the permissions, the sizes of the databases and all that. So that the central CMDB has all that information, and you can easily have reports and trending on that, which helps you make decisions on the long run. So what do I have to do to this minimal picture, which is really simple? You need a couple of C# services, one database, one website for the API, and some reporting tool, which most likely is going to be Power BI or something in this range, and then the local database. How do you scale this to thousands of machines? And that's the beauty of this design. It's super easy. First of all, you have thousands of managed clients. They appear automatically. What you need to do is you install multiple of these execution agents. They do all the same thing. They pick up from a to-do list. The difference is one is already busy. The next one can pick up the next task. If one task depends on another one to be finished, okay, this one is going to sit in the to-do list till the other one is done. But for example, if you have 1,000 instances and you need to collect the list of databases from them, you can do all 1,000 at the same time if you want to. I usually manage with about 4 VMs, tiny VMs, 4 cores each. I can manage about 1,000 instances and collect all the data. And each one of these 4 VMs runs about 60 instances of various types of this execution agent, so that it runs the parallel stuff. And again, each one works on one task at a time. So if something fails, only one task fails. Many years ago, I had the design to build an agent that tries to do 20 things in parallel at the same time by creating my own schedule. And then I figured out, no, that I'm reinventing the wheel. Let the other thing do it. This is something that could be easily replaced with running these execution agents on something of a Kubernetes thing these days. My problem is all my automation is running on Windows, and the Windows services are just easier. Thing is, and what I usually do when I need to scale out, I separate the central CMDB to only have configuration requests and settings and the current state in it, while all the collected data that I collect from the system gets into its own, I call it telemetry database. It's basically a big data warehouse that tells me how how the instance has changed over time. Having this on a separate database allows you for easy, if I have to recover, I only need the central CMDB, and I can start with an empty telemetry database and then reconcile later once I've restored the one. Depending on how much I collect or so, I usually add about 1 terabyte of data per 500 machines per year. It's the data I collect is usually highly compressible. So column store helps me a lot keeping this thing in check. And it's not just column store. I do also my own compression by, for example, if I collect the same data over and over again, I just extend the time frame on the record that I store. Yeah, it's the same list of databases for the last 20 days. And most likely tomorrow, it's going to be the same list of databases again and again and again. I don't have to create a new record every day to store that. I just say, okay, the last 20, 21, 22, 23 days, it's the same information. When it changes, it creates a new record. And usually, if you have very, very frequent configuration changes, it's a sign that something's not working the way it should be. Yeah. Yeah, every time you hire a new employee, you will have new permissions for that employee. That's fine. But if you add and remove permissions from an existing employee like 5 times a week, you might want to investigate if a process is doing the right thing or not. Yeah, and then these central execution agents write to the telemetry, and the reports might also go there directly and not through the central CMDB. And that's all you need to scale that thing up running. Could you have multiple telemetry databases? Yeah, you could have one for like configuration and one for size and one for thing. I never had the need. My guess is on an average machine, this whole setup can manage at least up to 10,000 instances with, let's say, 100 to 200,000 databases on them. There should be no problem running this through thing. I, on average, run 2 to 3 million agent from the central execution agent, 2 to 3 million tasks per day. And as I said, 4 tiny VMs with 4 cores each. And the reason it's 4 is because I have 2 data centers and I want 2 of them in each data center for redundancy. If half of them fail, it still works. So with 8 cores running a little bit of C#, I can easily manage 1,000 databases. 1,000 instances with more than 10,000 databases on them. And I've never, the execution agents are never the bottleneck. It's usually the clients in themselves that are too busy to fulfill all the requests I ask them because they have actual day jobs. So I might have to skip a collection and then come back 5 minutes later and do it then. Because I go in and be I have very short timeouts. If it doesn't come back quickly as I expected, I'm like, I back off and say, okay, I'll give you time. You're busy right now. Let's not torture you too much. So the central CMDB, the number one thing you have, and it's surprising how hard that is inventory. It's the hardest thing in every company to get everybody in the company on board to maintain a single list of all the SQL servers. It sounds like it should be so easy. Yeah. Okay, here's the list. And if you add or remove something, change that list. And because when you start automating, decommissioning is not high on your list. So it will take a while till decommissioning is fully automated. Yeah? So every time a DBA removes a machine, to get them to actually go to your table and mark that row as decommissioned, you would be surprised how hard that task is. And also, you will always detect, oh, there's a SQL Server we had no idea we have in a large company, because some other team installs some software that decides, oh, I can install an Express edition of SQL Server and store all my configuration in there. And nobody will ever take care of my backups or something, because why do backups? We're developers. We don't do that. We clone repositories. So having some tool that scans your environment and finds new SQL servers, and you figure out, oh, I tried to talk to this one for 3 days and it hasn't answered once. Maybe I'll check. Oh, someone has stopped the service and marked it for decommissioning, but didn't tell the CMDB. It just happens. The second one, and this might even be more important, once I know I have an instance or a database on it, I need to know who owns it. Who is responsible for the data inside? Because it's not me, the DBA. It's never me, the DBA, except for my own CMDB. For everything else, it's someone else in the company that is responsible for that data and can make decisions. And you need to know who that is. If you don't know that, you can't automate, because if something needs to be approved or checked, you need to contact them. And you can't just randomly call people up and ask them if they are that, which I've seen in companies happening, that DBAs spend half the time trying to figure out who can approve something, and then the wrong person might approve. Someone thinks he owns that data, but they don't. Yeah? Or what I always like in a company is, if I as a DBA get, oh, can you give me permission to access that database? Like, no, I can't. I mean, I technically know how to do it, but I don't know if you as employee X doing job Y has access to database Z, because honestly, I don't know. I don't know who you are, what you're doing, and I have no idea what the data in the database does. And this is a big problem. The larger you get, the less you know about each individual system. You will have your special cases where you know everything about them, because they are always troublemakers. But normally, I've worked in companies, I've managed databases that I've never seen, never opened, never looked at, and everybody is happy. And that's how it should be. Yeah? The DBA should not have to know what's inside a database, yeah, except for the reason of performance tuning, but not for, can I permission this or not? Yeah? The next one is relationships. Nothing to do with a dating website. It's the relationship between databases. This is my dev copy of this production database. You need to store that information somewhere. And this is where most commercial tools fail, that they don't have a place where I can do that. I can put in both, but I have no idea that they are, unless my naming conventions or something tell me this is the dev to this. I have no idea how they correlate or something. Or this is my DR copy of this database, or this is a scale out readable secondary of this instance. Yeah. So you need relationship between databases and relationship between instances documented somewhere in a consistent way. Next one is requirements. Oops, sorry, that was me. And the desired configuration. Desired configuration is, in your CMDB, this is how this machine should look like. This is all the settings. This is all the configuration values on each and every machine. And this is what it should be. And after that, schedules. Yeah, when should stuff happen? And we will come to that schedules in an automation system are not just time-based. Schedules are also event-based. And the last part is workflows and tasks for the agents to execute. It's basically once you have all this information, you can start building together workflows. What happens? So creating a new database is okay. We have one task to actually create the new database. Then you have to schedule a backup for it. Then you have to schedule maintenance for it. Then you have to give someone who requested that database permission to actually deploy the schema there. You have to give some service account access to the database to some role that the schema created in that database so they can actually use it and all that stuff. Yeah. And this is where the workflows and tasks come in. So let's have a look at inventory. List of all instances and how to access them. And you would be surprised how crazy this gets. And because it's amazing how third-party tools can put a wrench into your setup. In more than one company, I came across a database that is called C:\program space files /lutron /something .mdf. This is a tool that literally manages the lights in a building, and their install script has a mistake, and it uses the path of the database as the database name when it installs itself. So the C:\thing is where the MDF file goes by default, and that's the name of the database. That kills every backup script I've ever seen. Because you will probably put the name of the database in the backup file, and now there's a C:\/ in there. So I've seen database names with GUIDs. I've seen instance names that are weird. I've seen cases where the server name doesn't match the instance name because some tool requires it to be changed to something very specific. Horrible things. And your inventory needs to be able to do this. So you not just need an instance name. How is your instance name? I also store it at server name. So when I get data back from the instance, I can like match it to where it needs to be. Again, I learned that the hard way, that the name you use to access the server is not apparently the name that the server thinks it has. And then the third one is I usually store a connect string that gives me the ability to put in some port restrictions or special settings to access an instance. So when I refer to the instance, I use the instance name when I set up configuration or something else. But when I actually try to connect to the machine, I use the connect string. And if I get data back from it, I use the @server name. I learned this over the hard thing is in the first company I worked, these three were always identical at the same entry. Yeah. But since then I came to other places and yep, @server name, not always the instance name and so on. So this is stuff I learned over time to have here. I usually also need a list of all hosting operating system environments. And that's a new fancy word that Microsoft created a couple of years ago, OSE, operating system environment, because we now have containers, VMs, servers, the cloud, and many, many other things will come. And they are all basically an operating system environment. You either have an operating system directly on the hardware, or you have it virtualized in a VM, or then you might have a container that is either on a VM or on a physical server that gives you partial access to an OS. It's all there. I now call it OSE, and therefore I don't have a problem, but I also need a list of all of them, because usually to get things like free disk space or so, I have to talk to the operating system and cannot get that information all the time through SQL Server. And lots of performance counters are only available directly from the servers and not from SQL. What you see on the right side of the screen is that little data model I had to come up with to deal with what's out there today. And that data model does not yet include contained availability groups, because for contained availability groups, I need some extra complexity to deal with that, but that will come soon. This basically takes the instance, and it can either be running on a failover cluster, or it can run directly on an operating system environment, and that can be either on a container VM, all that. And all these at some point end up on some physical server that is in some availability zone, which is a term I use now for it because it's used in clouds, and availability zones are in regions. For me, region is a data center also, and availability zone is a room within a data center. That's how I have that. In the cloud, the region is usually the town that has multiple data centers, and the availability zone is one of the data centers. But then within the data center, they don't have different zones. It's when you run your own data center, you're usually not building 5 of them in one town. You have one, and then you have like separate power distribution or so in 2 rooms or something to get some kind of independence between them. Yeah. But that's the model. And while I'm showing this code and all that, I will at the end give you a link to a website that is not yet up and running, but end of January, beginning of February, that should come online. And I will share all the code that I've wrote over the last years about the inventory and talking to the machines and collecting data from them as an open source project that you can all use and hopefully also contribute over time to it. So that you have a starting point and you don't have to start from scratch like I had to. So then, of course, you need a list of all databases, but if you already have the instance list, you can actually query the list of all databases. Why do I maintain a list? Again, it's about this desired configuration management. If a database gets dropped and I maintain my list of databases by collecting them and I don't collect it anymore, how do I know if it's gone because someone deleted it on purpose, or if it's gone because it dropped off the earth by accident? So you still have to manage a list of my inventory. You can create like reports or so that show you the difference between what is collected and what's in your list. And then you find, oh yeah, someone on the weekend in an emergency had to deploy a new database and did not go through the proper channels. So let's fill out the paperwork and update the CMDB correctly because there's one database too much. Or some database actually got dropped by accident. You can restore it and do this thing. Hierarchy. When you manage lots of machines, you want to group them into piles of machines that you work on together. Yeah? So that you can, let's say you have an availability group that has a primary, a read-only replica, an AJ machine in the same data center. So 3 servers in one data center. And then you have probably a pair on the DR side, because in DR case, you don't need the read scale anymore because all the reporting tools are not highly available anyway on the DR side. So, but let's say 5 machines. These 5 machines should be configured exactly the same. So if any kind of failover happens, there are no problems. So it would be great if in your CMDB, you can like group them together so that you're not actually managing 5 independent configurations. You're managing the configuration for the group of machines. Yeah. And so instance, you have an instance. you have an availability group that sits on that instance and might fail over to another one. And you have a database. That's also hierarchy. Yeah, that if you have 10 databases in the same AG, you might want to have all 10 databases to have the same configuration. Or you might not. Yeah? 9 of them might have the same configuration and one might have a different one. And again, if an AG runs on multiple instances, you want to have these, or you have multiple AGs on the same instance, you might also want to give them the same configuration. So in my example here, I show how I'll do this. When I have in my tables a value in each one of the 3 tables, then the one with the lowest hierarchy wins from a perspective of the database. So if my instance has a value of 1, the AG of 2, and the database of 3, and I'm looking for the value for the database, the 3 in the database is an individual setting for the database and therefore gets picked. If I put a null value for the database in my hierarchy, then the database would inherit the value from the one level above, with which the AG that groups together multiple databases. So I don't have to specify a value for the database. It takes the one for the AG. If I change it for the AG, it automatically changes for all the databases. Same thing. If I do the instance and have nothing, no value configured for the AG, but then from an AG perspective, it would be a 1. But since I've specified it again in the database value has priority and therefore would pick the 3 again. And the case where then both AG and database are null, then it would inherit from the instance. And this goes in my data model through the whole thing. Yeah. So if I have a table, the table might not have a setting for its. You can override the settings for this table, how often you want to run update stats, but you might want to set it for a specific database. If you don't like it for the database, you can set it in the AG. If you don't like it for the AG, you can set it for the instance. And even higher up, the highest level of the hierarchy is my default value for each and every setting that I have. Like backups, once a day full backup, or backups once a week full backup on the weekend, or something like this. Yeah? Unless I override it, it uses the default. So in that configuration table, there's a lot of nulls because you don't want to specify specific values. You want to inherit as much as possible. That makes managing large amounts of machines super easy. Ownership, we talked about this before. Who owns the data? The people defining everything that's below that will come right now. Who can access? Who can approve access to that data? Might be the owner, or the owner might be delegating this to someone else. I often see that like some head of department owns the database, but he trusts some person in his teams to manage the access. You want to have someone who can approve deployments. You want to have data about who can approve changes to the database, who can approve cost. You get a request, oh, we want to have not 1 full backup per day, we want to have 5. Okay, we can change the automation and do 5 full backups every day, but who is paying for the storage that we need for it? So someone has to approve the cost. And again, that might, in a smaller company, all these roles might be the same person, or it might be different people in even different departments. Yeah. Who is to contact in case of an emergency? Something's wrong with the database. Who should we wake up? Who should get notifications? Like, we are planning on doing an extensive index rebuild this weekend. Who wants to get that message? And for alerts, database is down. Who should we wake up if something's wrong? Yeah. The difference between emergency and alert is you get all the noise from the alerting systems. Emergency, you get someone from the DBA team already looked at it and we can't fix it. And therefore we need to inform you that you have a bigger outage. So that's the different understanding level on my end. Again, I already have a data model to do all that. And as I said before, I will share this very, very soon with public. I just need to clean up a lot of things before I can do that. But it contains all the information to contact people, group them into teams, and give them all the thing. It even handles the cases where your company is actually multiple companies, and you have something called information barrier. If you work in a company that has information barrier, you will be very thankful that the system can deal with it. If you don't have it, just don't put more than one record in that table, and you will never get annoyed by it. It's just a way large corporations often that two teams are not allowed to talk to each other, and this makes sure that you can only see information about the databases that are within your same area. Yeah. It's often there's a setup that you have like a sales company and a manufacturing company, and they're both owned by some other company, and that one employs a third company that does all the IT stuff, and that's where you and your database team would be in. So you can see all the data, but the sales company is not allowed to see the manufacturing data. Yeah. Or banks, often the investment part and the savings part of a bank need to be separated, stuff like this. So if you are there and you know what information barrier means, you know it and you will be thankful. If not, just ignore it. The next one I said, relationships. As I said, availability and scale. Who is the primary? Who is this disaster recovery, high availability node? Who is read scale? All that. Environments. Who is production? Who is development? How are you related? Sibling databases is another thing that I come across a lot. Many systems have like a new database every year, and they put 1 year's worth of data in a database, and then next year they create another one. From a schema perspective and a permissioning perspective, all these databases are identical, but from a data perspective, they are not. So they are, for me, they're siblings. You have the same DNA, you have the same schema, but you have different content in you. So if I need to roll out the schema change, I have to do it to all of you, but each one has different data in it. Yeah? This might also be the case where you have a multi-tenant system and you create one database per tenant. Same thing, you have the same schema, you might do this. You might add another relationships based on versions, like this is the old version, this is the new version of the product, stuff like this. Again, I've come up with this. For the requirements, this is a lot of information that DBAs need to know, but DBAs are not the one responsible for setting it, like data retention. Yeah, DBAs might be responsible for deleting old data or dropping old partitions or something in a table, but the DBA does not define how much data needs to be kept. That's whoever owns the data in the database's responsibility that says, okay, we need 7 years, we need 30 years, we need 3 months, we need 1 week. DBA doesn't know. The person who owns the data knows usually and can set the data retention, both for data inside the database and data, how long do we have to keep backups. I have cases where backups are needed just for recovery, so you keep them like a month or so around and then you get rid of them. And I know data companies that I've created a database 30 years ago and they still take backups and keep them because they have to maintain it backups for 30 years because it's a regulation thing. Backup retention, I said before. Security class, is this machine, does this database has like publicly available information in it? Like you have a copy of all the zip codes and city names in a database. Yeah, that's information you can literally Google or download somewhere. But on the other hand, like your customer list might be more of a security thing because not everybody has access to which are your customers. And then when you go even deeper, like personal information, like HIPAA, and or in the financial industry, like the bank account of a customer, which is even more secure, because you might have employees that might have the need to know who the customer is, but they definitely don't need to know what their bank account number is. Thing is, which kind of availability do you need for a database? Yeah, I've seen databases where the owner said, "Yeah, if we lose the data, okay, fine, give me an empty database and we can continue our business, and then we reconcile later." And other cases where they said, if the database is not available for 5 seconds, the company is bankrupt. Yeah, don't trust that statement, but it's a thing. Consistency. How important is it that all the data and all the constraints and everything is there? So, for example, if there's a deployment problem and the check constraints can't be reapplied to the database or to a table, can the DBAs allow the database to go back online or not? Information like this. And I listed availability twice. Must have been late when I wrote that slide. Desired configuration. We talked about that. This is, I have defaults, and then in a hierarchy, I create overrides things. So another example where I have a hierarchy is I have a default value, yeah, like backups daily full, yeah. But then for the environment development, I might change that to weekly full. Because, yeah, in production, I want to do a daily full backup, but in development, once a week is good enough. Yeah. In QA, I might say no backups at all, because in QA, we restore production data and just see if everything works. So we don't need backups because we do backups in production anyway. Thing is, I might have settings depending on the location. It's like, okay, all the machines in this data center are primary, and all the machines in the other data center are DR, because that's our DR data center. Stuff like this. What is the role of an instance? This is a primary. This is a read scale machine. Yeah, is all desired configuration. The reason I want that set in the CMDB is so if I see it changing out there in the field, I know something happened. So, for example, if I have an automatic failover between my primary and my AJ, the next time I collect the information, I will see, oh, the AJ is not a primary and the primary is now AJ. So I had an event that caused a failover. So I can react to that. I can either alert people or do an extensive check if everything's fine, or I just notice it and keep a record of it and everything runs fine. And this is the desired configuration, I like things. So schedules, this is the last big one we have to talk about. Schedules could be very simple, yeah, like yearly, quarterly, monthly, all the typical things that SQL agent can schedule, yeah. But then I came along very special requests. Can we schedule this to run every long weekend? What's a long weekend? This is when it's Monday is a holiday or Friday is a holiday. So you have an extra day. So for example, let's do index and update stats with a 5% sample rate every weekend. But if it's a long weekend, we have that extra 24 hours. Can we do on long weekends and update statistics with full scan? Yeah, stuff like this. Or you don't want to do something on certain days, yeah, like send out reports. Don't do it on bank holidays, or don't do it on regular holidays, or stuff like this. So you want to have the ability to schedule around your business. So what I usually try to keep is some kind of a calendar with special events that happen in the business that I run in. Yeah. Other schedules I need is every n weeks, days, minutes. That's thing. But very common schedules are after schedule X or after event Y. So don't start DBCC check DB while the backups are still running, or don't do an index rebuild while the backups are running. So you want to schedule the backup. You normally know if you just schedule it by time, you know that your backup usually takes 2 hours. So after 3 hours, you schedule your index maintenance. But what if, for whatever reason, one of your storage arrays has a little bit of a hiccup and is very slow today, and your 2 hour backup takes 5 hours? Then you're putting an index rebuild on top of that. That basically creates a log file that is so big that your backup size doubles, and then your already delayed backup takes even longer because you didn't wait with the things. Yeah. So you need to be able to schedule things that depend on other things. Yeah. And then same as you not just want to be able to do something on long or holidays, on long weekends, you also want to skip something on long weekends, or you want to skip something during code freezes. Yeah. So if you have, for example, scheduled an index rebuild, which kind of you might not want to do it during a code freeze. And it depends on what you're doing. Yeah. Or you might not want to do things while you are in HA or DR. Yeah. So you don't want to run backups while you're in DR, because you know you're going to go back to the primary in like 3 hours, and you don't have a backup infrastructure set up on your DR site, or you don't have all the capacity. So you only want to do the most important databases while you are in a DR scenario. Yeah, stuff like this. You don't want to do something during high load. SQL Agent kind of has that setting. It has the opposite. It can do something during no load, but I think it's more important to don't do it during high load. So you're seeing the CPU is at 100%. I don't want to start an index rebuild right now. It's probably not a good idea. A, it will take forever, and B, it might even compromise whoever is running that intensive query and slowing down everything already to begin with. Yeah? And then the information, if for whatever reason you couldn't keep a schedule, do you want to catch up or skip? So for example, SQL Agent only has one option. If the job is running while the next schedule run of it comes, it skips it, and it will never run that one again. So for example, if you want to do log backups every 5 minutes, and a log backup takes 6 minutes, you will skip one. And that's probably the right thing to do. But if you run full backups once a week, and for whatever reason your full backup took more than a week, you might want to start another backup not a whole week later, but as soon as the other one finishes. So all these extended schedule. And again, as I said, I spent already a lot of time building all this, and it will be in the shared project. Last topic, workflows and tasks. It's basically workflows define what happens step by step. Do this, once it's done, do the next one, do the next one. And it's used to break large complex tasks into small units. It just makes it happen. The tasks are then, okay, in this step. So option one could be like archive yesterday's telemetry data. Step two, collect telemetry data from all our instances. And then tasks would be created to run in parallel the collection of all that information, because you don't want to do this. And this is one of the major things where you have to rethink how you do things once you can't do it within one cycle. And with a cycle, I mean like within a day. If you start doing backup, at the very beginning, I did one job that went from machine to machine and did the backups. And after 2 or 3 hours, it was done and everything fine. If I would do this today on the machines I manage, it would probably run for like a week before it's done. Yeah. So I would only have one backup of each system per week, which is not enough. So I had to think about how can I do things in parallel. And the tasks do exactly that. It's used to run things in parallel. You put it in the queue, the agent pick it up as quickly as possible. You have multiple agents that do the same thing at the same time, just on different machines, and therefore it works fine. It's a very bad idea to run the same tasks against the same instances. So the queuing thing is clever enough to iterate across the board before it runs on the same machine again. It can still happen that 2 or 3 tasks run on the same machine. But for example, you want to collect the schema of all your databases. It will not, if you have 20 databases on the same system, it will not run 20 threads to do all 20 databases at the same time. It will do one database on the first instance, then do one database on the next instance, do a couple of instances in parallel. Once they're all done, it will come again. So it tries to not torture the systems. The local DBA database, as I said, has the desired configuration for the one instance. It has all the procedures to do the collections, the validation, the implementation, and therefore all my agents need is execute writes on these stored procedures, and I can fully control who can deploy that. And therefore, my agents cannot go rogue and cannot be hijacked to do high privilege tasks. They can only do something that is coded in these stored procedures. The agents cannot go out there. I've seen third-party products. If you hacked into the agent by just telnetting to the port they were listening at, you could instruct them to run everything as sysadmin. It was a nightmare. And thing is, and I sometimes use it to buffer for collections and logging. So sometimes I want to make sure that I can collect something every couple of minutes. So if my central system is not working, it will store the information in the local database and then push it to the central one at a later point in time. So how do these execution agents work? Super simple. I have a procedure that will collect the data. Yeah, it's collect logging data. It's a very simple stored procedure. It has a high watermark, so it knows all the rows it already has collected. This is stored somewhere in the central system, so it will not ask for the same data twice. And this is a very simplified version of that stored procedure with lots of details not there. But it basically pulls that. The most important thing is whenever I collect data, I include at server name, so that I know where the data came from, and then I can store it in the right place. And this is why I need the at server name, so I can match it to which instance this data and which thing it belongs. On my central machine, so this creates a result set, the table with all the rows and the columns that I wanted. And what I then do, I take that, the agent takes that table, which is usually a couple of rows, a couple of thousand rows, maybe 500,000 rows on something gigantic. If I have a database that has like hundreds of tables or something, it might create, if I get the column list or so, it might get into the 500,000 or so rows. And I pass that table as a table valued parameter into a stored procedure on the other end. So it basically takes the data from one stored procedure and passes it on to the next one through that agent. And then you will see on the next slide in C#, this is really super simple to do. And that other stored procedure just takes the data and dumps it into the right table. And with that, it allows me to make changes on both sides without the other side being affected, as long as the table in the middle doesn't change. It works great. If that has to change, I have to synchronize that both changed before. But what it allows me, if I want to, for example, add another column or something, I would create a collect logging data to store procedure, have that extra column in there, and then have two store procedures that will then deal with the missing column when talking to the table. Basic stuff that's done in data warehouses for decades. I just adopted it and used it here. So how is this done in C#? And I'm not a C# developer. I took a lot of C# code and extracted the bare minimum that's needed to run this. There's no error handling. There's no nothing. That's not about it. This is not about how to write good C# code. This is show how to do this feature. So I have to create a data set, and then I execute a store procedure on the source database, which is my little DBA database, and the source.command is the name of the store procedure that I need to run. I execute that. And on the target database, I execute again a store procedure that I specified the name for. And then I create a new SQL parameter, the result set, which has from the result set the table that came back. And again, there's no error handling. That table could be not there, so that should be checked and all that. But for simplicity is, so I query my first database, I get the result set in a data set back, and I pass that data set into the other store procedure. 2 lines of code, and I just moved thousands of rows from here to there in a very efficient way. It's faster than single row inserts. It's not as fast as bulk inserts, but the flexibility of having store procedures on both sides where I can make changes and deal with different versions and all that, it's worth it. For example, if you collect DMVs, every time a new version of SQL Server comes off, DMVs, and these sometimes even in a CU, DMVs get additional columns. So if you want to collect older and newer versions at the same time, you have to deal with the extra columns. You want to have all that in the same table. This system lets you easily create different store procedures for each version and then don't have to deal with that. Yeah. And then to make that parameter an actual table and understand C# to do the right thing, you have to set the SQL DB type to SQL DB type.structured, which tells it this is a table that we're going to insert. And that's basically 2 lines of code that allow you to do that. The whole agent is probably 200 lines of code. With all the error handling and picking up the commands and parsing them. So they're really simple. And that was the basic idea. Keep it simple, just make them do one task, and that task very good and fast and reliable. If something happens, they restart, Windows restarts them automatically, and they keep going. Other central execution agents besides the one that moves data. And by the way, this works in both directions. I can use this, if I just change source and target, I can move data from and to between these databases in both directions. It doesn't care which one is the source and which one is the target. So I have procedures that collect something on the central system that says, okay, give me all the settings for this one instance, take that table and push it down to the local database. Other central execution agents, I have one that does PowerShell. And if at the end of the PowerShell, I select basically the data, I can also, again, push it to a store procedure. So this is how I get like the free disk space and something on machines. I have an agent that can deploy a DAC pack. So if I have to update that local DBA database on all my instances, I use that one and use a DAC pack project from Visual Studio or soon VS Code and Azure Data Studio. They can also create DAC packs very soon in a good way. I have one that can send and receive email. I don't not use the SQL Server email stuff. We decided to use our own because it mostly with security things, and SQL DB Mail has some SQL DB Mail lets you literally fake who is the sender, and you can, and I don't want to expose DBAs to be able to fake something and just tempt them to do something stupid. So we don't run it. So therefore, I have something that can call a REST API and get some data from it, or set some data in a REST API. So that's how I communicate with other teams. Yeah, one is the one that I call the data. The other one is where I'm an agent just sits there and says, okay, ask me something and I will give you the data back. It's basically a wrapper around the store procedure, but it has some extra fancy technology to figure out if whoever calls me is actually the one who calls me and is authorized to do so. I have an agent that can talk to PostgreSQL. So everything I can do on SQL Server, I can technically also do on Postgres. That's in the infant state, but it's very promising, and so it might soon be able to manage both SQL and PostgreSQL. The licensing gods will thank you for not spending so much money and use other databases. I have one for Oracle, but that one I cannot share. Maybe in the future. Right now I cannot, but it's not that hard. If you can talk to SQL, you can talk to Oracle. And maybe in the future there will be more, but that's basically what I needed. Lessons I've learned. I use UTC when referencing dates and times. I gave up on trying to use local time. It's just not possible. Whenever I get something, I remember the UTC date. I might have a second date in the same table that is the local time, but every decision, every math, everything sorting, grouping, everything is done based on UTC. The moment you have more than one time zone involved, you will have that. The moment you have more than one country involved, you will need that. Because if you're like in the United States, you are fine. You have your 4, 5, 6 time zones, depending how many islands you include in your setup, you're fine. You change daylight savings all on the same day at the same time, except for in different time zones, it actually happens at different times. But if you have systems in Europe and in the US, Europe and the US change daylight savings in different weeks of the year. So nightmare, UTC is the only time that will give you correct time, no duplicates, no gaps, no nothing. I use something I call cycles instead of date ranges, and this is for performance reasons. So I created cycles like every 5 minutes. I have a table that has an entry for every 5-minute period. So the from to becomes one ID. So if I only have to do the checking from to the between once and not in each and every query. Afterwards in a query, I can group by that cycle ID. I can just join to that cycle ID and get the begin time or the end time of that cycle. It's like, I don't care if the backup was done at 9 p.m. or at 9:01 or at 9:01 and 3 seconds. It's roughly at 9 o'clock. That's good enough for my full backup. And or for backups, for full backups, I might even only want to know, did it happen today? I don't care when it happened today when I check if I have all my backups. As long as it happened today, I'm good. I don't care at the time. And these cycles make that much easier than having logic each and everywhere blending is. Yeah, that's some example. And then assume every name is Unicode. You will come eventually to other countries that have very funny letters in their alphabet. And if your database is not Unicode and uses Unicode strings, you will have problems storing database names. And I gave you before, the C column backslash doesn't require Unicode, but still required characters that you would not expect in a database name. The SQL Jedi project is what I'm setting up right now. It's for justifiable enterprise database infrastructure, not to be confused with any science fiction thing. Any naming coincidences are absolutely coincidental and not be done on purpose. It just happened that the starting letters form a name that was used in some other science fiction project. Yeah, It's open source and open book. So I'm not just providing you with the source book. I'm also providing you with hundreds and thousands of pages eventually over time of all the documentation I wrote for it with the instructions on how to program it, why I made the decisions and why I did. So if you ever have to change something, you understand the implications of it. It has run books in it, how you deal with it, and sometimes even examples from if something went wrong and why we had to change it or something. Yeah. Yeah, you will not be able to find me in the community zone because the conference is over, but you can still email me at tg@grohser.com. I know that usually most people don't have questions immediately, but they come up later. I'm very happy to answer them if you have them, or if you want to join the project or help something like this. The URL will be sql-jedi.com. If you type it in right now, you get the typical, you want to buy the domain thing, but I have it. I'm working on it. Fingers crossed, by the end of the month, everything should be up and running. It will basically have the source code on GitHub and have the PDF downloadable on that website and the instructions and some interface, how to like request features and give commands and stuff like this that will be there and on GitHub kind of combination. Good. There's no session evaluation, but I will still say thank you to you one final time. My email, if you haven't screen captured it yet, that's pretty much the last chance. And so far, I have not seen many questions. So yeah, if you have any questions, type it into the chat. I try to answer. Yeah.
Thanks, Thomas. I also want to mention to folks, I did go through and mute everybody but Thomas earlier on. So if you have questions, you might find you have to unmute yourself manually or use the chat.
I can put my email address in the chat. That would be helpful. Sure. Meeting group chat. That sounds good.
And we did actually have a question come in from Mauricio. Do you have a script to install SQL instance like SQL Spade was in 2016?
Yes, I have a script that installs SQL Server and patches it to the desired patch level that is defined in the CMDB. It can do about half of the scenarios you can do with SQL Server. It cannot do FCIs because I rarely see them anymore in the area I work. But it shouldn't be hard for someone to do it. It's just thing is, but on non-FCIs, I can do default instances, named instances, combination of default instances and multiple named instances, combination of multiple named instances without a default instance. I can do named instances on separate IP addresses and have them all listen on port 1433, which is insanely convenient that you have basically multiple default instances on the same machine. That one was the first one I actually wrote the install for. And I can do both service accounts and group managed SQL, group managed service accounts, GMSAs. That's the scenarios I can do. I cannot yet do Azure Active Directory stuff, but that should again not be hard. I just never had to do it for anybody because all the companies I worked for so far did not choose Microsoft as their favorite cloud provider. One day some will, and then I will have that added too, or someone else beats me to the punch and adds it. But yeah, it's mostly PowerShell. It uses one external component in PowerShell that needs to be installed. There is one, it's from Microsoft. There's a team within Microsoft that provides all the PowerShell functionality that is not built into the Windows PowerShell. It's weird. Why they're not just implementing it in the basic PowerShell thing? And it's the only project that gets smaller with every version of Windows. It's hilarious. Every time a new version of Windows comes out, they have a smaller version of their project because now the features are available in the Windows PowerShell that comes with Windows. It's mostly about that stuff. When you install SQL Server, you have to do like set group policies and do the local permission thing that you can run as a service, and that you can do the execute as part of the operating system, and all these extra permissions that you need to do. That's the stuff that I'm setting usually. But for that, I use an external project that I legally cannot distribute, but I'll have the instructions how to download it and integrate it. And yeah, it's there. Will it do every case? No. But it does a lot. And it can handle mount points. It understands mount points, and it will also like format your hard drives and everything if you configure it in the CMDB. So if you tell it like, okay, the first one is the operating system, the second one is the data drive, and the third one is the log drive. Or you can tell it, oh, if you find a terabyte drive, that's the data drive. If you find a 50 gig drive, that's your temp-db drive or something. Yeah, you have multiple choices how to define that, and it will go out and do the installation. Yeah. And it can do every version of SQL Server starting at 2012, I think. I cannot go back any further because they changed the setup at some point, and I never wrote something that deals with the older version. I think 2012 was the first one that out of the box could do slipstreaming of the CUs. And that's why that's the oldest one I support right now. And again, if you newly install something older than 2012, yeah, you might have other priorities than automating in your environment. But yeah, it works all the way to 2022. So good. Any other questions? Good. Then thank you very much. I will stop sharing my screen. Or I might already have done that. And thank you. No,
Oh gosh.
I gave you the email address. Yeah, it's in the chat, so you have it.
I just realized I was talking on mute. Thanks for the great talk, Thomas. I know my brain is full, so I'm probably gonna have to watch again after David uploads the video.
Yeah, I have this problem that the topics I talk about, they're just not 30-minute quick things. It's the whole documentation I have so far is close to 2,000 pages. Yeah, for the whole thing. That's why I have to put it in smaller pieces, because if I release 2,000 pages in one go, nobody's gonna read it. Yeah, so I have to. That's what takes time, to cut it into small pieces. What do you need? And the problem with automation is it only really works if you cover all your bases. So my whole CMDB has like 600 tables in it. Yeah? Again, if I give you 600 tables in one go, you will never be able to deal with it as a shared project or something. I have to cut it down to the bare minimum, and then over time add to it, and so that people can actually follow that. Poor guy who comes in like 5 years from now and then gets the 600 in one go again, but hey, he can look at the history of the project. Anyway, thank you everybody. Thank you very much for listening and spending your lunchtime if you're in the US, or your evening if you're in Europe, or the middle of the night if you're somewhere else. And hope talking to you everybody soon again, and have a great day.